clean me, I can mix with oil, we're just not compatible.
Relax, I brought soap.
And that's exactly what we are talking about today. How soap uses chemistry to clean oil.
Hi everyone. So today our group is going to talk about something that we all use every day, soap. So basically, have you ever wondered how soap is work and why it was related to chemistry? Turns out, soap is actually a great example of chemistry in your life. Basically, soap is made from a chemical substance from fat or oil. In chemistry terms, soap is actually a salt from fatty acids. It might sound complicated, but it's actually very cool.
So I'm going to explain how soap is made through a chemical reaction called planification.
This happens when fat or oil react with a strong alkali such as sodium hydroxide or potassium hydroxide. From this reaction, we get soap and glycerol.
So basically the fat or oil react with the alkali and the chemical reaction take a place that produce soap.
In chemistry, these fats are called triglycerides. Triglycerides are commonly found in oil and fat that we use in daily life. When triglycerides react with an alkali, the bone break and new substances are formed. When we say the bone break, it means the ester bonds in triglycerides are broken. This process is known as hydrolysis, which is something that we learn in organic chemistry, especially when studying esters. Since triglycerides are ester, saponification is actually a type of ester hydrolysis.
As a result of the reaction, soap molecules are formed and glycerol is released as a byproduct. Fun fact, sodium hydroxide make hard soap like bar soap and potassium hydroxide make liquid soap. So the type of alkali we use affect the final form of the soap, which is why bar soap and liquid soap feel different when you use them. So every time you wash your hand, you're actually using the product chemical reaction. Pretty interesting, right? Now, let's talk how soap actually cleans.
Most of the dirt on our skin and clothes isn't just dust. It usually mixes with oil and grease. Oil is non-polar, while water is polar, so they don't mix. So that's why cleaning with water alone cannot properly clean them.
A soap molecule has two different ends. One end is the hydrophobic tail, which is nonpolar and attracted to oil and grease. The other end is the hydrophilic head, which is polar and attracted to water.
Here are the process on how to clean grease on a cloth. First of all, soap or detergent will ionize in water to produce free-moving soap anions or detergent anions. The hydrophilic parts of soap anions or detergent anions dissolve in water, while the hydrophobic part dissolve in grease. Movement of water during scrubbing and agitation causes grease to pull away from the surface of the cloth, and the hydrophilic part of soap anions or detergent anions surround the grease. Grease floats to the surface of the water and will break into small droplets. The small droplets will not reattach to the surface of the cloth due to the repulsion of negative charges of the hydrophilic parts on the surface of the grease. The droplets then are suspended in water, forming an emulsion. Rinsing with water causes the surface on the cloth to become clean because the grease droplets are left in the water.
When we wash our hand after eating oily food, water alone cannot remove the oil. This is where soap help because the hydrophobic part going to stick to the oil while the hydrophilic part allow oil to be washed away with water. This process forms a structure called micellar, which trap dirt and oil.
Other than that, soap does not only remove dirt but also remove germ from our hand. Soap molecule can break down the outer layer of a bacteria and some viruses. When we wash our hand with water and soap, the germs become trapped and were washed away, helping to reduce the spread of diseases. This is the example of when one of the example actually where we are in the COVID-19 pandemic. Remember when all of the world learned how to wash hands properly after going outside to make sure there's no germs are left in the hand so that we don't spread the diseases to other people.
This special structure is why soap is very effective in cleaning and maintaining personal hygiene.
So, in simple ways, soap acts as a bridge between grease and water. It allows two substances that normally repel to interact. So that's why soap is such an effective and powerful cleaning agent.
Now, let's quickly compare soap and detergent because many people think they are the same.
First, let's talk about soap. Soap is usually made from natural fats and oils through a chemical process called saponification. Because of this, soap is considered more natural. However, soap has a weakness. When it is used in hot water, it reacts with calcium and magnesium ions. This reaction forms something called soap scum, which is that white residue that we sometimes see on clothes or sink. Because of this, soap becomes less effective in hot water. On the other hand, detergents are made from synthetic chemicals. Detergents are designed so that they do not react with calcium and magnesium ions in hot water. This means detergents can clean more effectively, especially in areas with hot water. That is why detergents are commonly used for laundry and dishwashing. In terms of environmental impact, soap is generally biodegradable, which means it can break down naturally and is less harmful to the environment. Detergents, however, may contain chemicals that are not easily biodegradable and can contribute to water pollution if not properly treated. So, to conclude, soap may look simple, but it involves a lot of chemistry, from its structure, its production, and even how it cleans.
Soap or detergent?
Depends, chemistry decides.
But the way chemistry keeps us clean,
Soap may be simple, but it shows how chemistry is part of our daily life.